Hello, welcome to Sigma Tech Consult Limited. Today we'll learn mathematics. Okay, so we'll learn prime factors. Let's look at some of the learning objectives of today's class. By the end of the lesson, you should be able to define prime factor, and you should be able to solve problems on prime factors. Okay. So first, what is a prime factor? What is a prime factor? So a prime factor is a factor of a number that is prime. Okay? It's a factor of a number that is prime. Then what is prime, or that is a prime number? Okay? A prime number is a number that has two factors. One and itself. So all prime numbers have two factors. That is one and their self. That is for all prime numbers. They have two factors. One and the number in question. Is that okay? Example of prime numbers are 2, 3, 5, 7, 11, 13. These numbers you have here, they have just two factors, which is one and themselves. Now, what is a factor of a number? Okay, to take you back to what you already know about factor of a number, if the factor of a number is a number that can divide that number, okay, without a remainder. So any number that can divide a certain or a particular number without a remainder is the factor of that number. For instance, 2 is a factor of 4 because 2 can divide 4 without remainder. So we say 2 is a factor of 4. 3 is not a factor of 4. Why? Because if 3 divides 4, there will be a remainder of 1. 3 divides 4, it will go once, then there will be a remainder of 1. So we say 3, even if it's a factor, of course, all numbers are all factors of at least a number. Even if 3 is a factor, but it is not a factor of 4. 3 is now a factor of 6 because it can divide 6 without any remainder. It can divide 9 without remainder. It can divide 12, can divide 15 without remainder, and so on and so forth. So prime numbers are those numbers that they have just two factors, one and itself. Is that okay? So example like we have given is 2, 3, 5, 7, 11, 13, 17, 19, and so on, 23, and so on and so forth. Is that okay? So those numbers are prime numbers because we have only, what's it called? We have only two numbers that can divide them. Okay? So we're going to look at, we're going to look at some examples of how prime numbers are given. Is that okay now? So it is good we mention because it is always confused that 1 is a prime number. Some people confuse it to be so, but know that 1 is not a prime number. Do you know why? 1 is not a prime factor. Neither is it a prime number. It's not a prime factor. So what that simply means is that from the definition of prime factors, okay, we say prime factors, they have, prime numbers have two factors. But for one has just one factor, which is itself. Okay? It has just one factor. All prime factors, all prime numbers must have two factors. But in the case of 1, you just have 1. That is why we say that 1 is not a prime number. Neither is it a prime factor of any number. Do you understand the point now? Okay, so let me give you an instance of what prime factors of a number. Now let's say the number, let's look at the number 12. Let's look at the number 12. We know that, yes, 1 is the factor of all numbers. 1 can divide any number. 1 can divide any number because the answer will still give that number. So 1 is a factor of 12. We know that 2 is a factor of 12. We know 3 is a factor of 12. 4 is a factor of 12, right? 6 is a factor of 12. And of course, 12 itself is also a factor of itself. Do you understand? Now, look at these numbers. They are all factors of 12. Our attention in this lesson is to know in these factors that we have of a number, which of them or how many of them are prime. Prime means how many of them are prime number. How many of them are numbers that can only be divided by 1 and itself. Look at all these numbers here. We have 1, we have 2, we have 3, we have 4, 6, 12. So how many of them can be divided by 1 and itself? If you look at this place, only 2 and 3 are the prime factors that we have in the factor of 12. 12 has 1, 2, 3, 4, 5, 6 factors. Out of that 6 factors, we have just 2 and 3 as its prime factors. Do you understand the point? Okay, so that's the concept of prime factors. Let's look at 20. Okay, let's look at 20. 20, we have, so why we said that 4 is not a prime factor is because 4 can be divided by 2, 6 can be divided by 3, 12 can be divided by 2, by 3, by 4, by 6. This can be divided by 2 also. This can be divided by 2 and 4. So these ones, they all have factors that are not just 1 and itself. So that's why we didn't consider them, okay? I just had to come back here and explain that. All right, so let's look at a number like 20. 20. Okay, 20 we have 1 as a factor of 20. 2 is also a factor. 3 is not a factor of 20. Remember, 20 is an even number. Do you understand that now? All right, so 4 is a factor of 20. 5, factor of 20. 6 is not a factor of 20. 7 is not a factor of 20. 8 is not a factor of 20. 9 is not a factor of 20. 10 is a factor of 20. After 10, then we have 20 as also a factor of 20. In all this, we have 1, 2, 3, 4, 5, 6 factors of 20. How many of them how many of them is a prime number or a prime factor of 20? We say that just like 2 and what? And 5 are what? Prime factors of 20. Okay? Of 20. Prime factors of 12. Do you understand the idea? Okay, so any of these numbers that I listed, any of 2, any of 3, 5, 7, 11, 13, 17, 19, 23, and so on. Any of them that you see as a factor of a number is the prime factor of that number. Do you understand? Okay, so we're going to look at some examples from our Examguide learning app, and we'll see some questions in your basic exam that are related to what is it called? Prime factors. Is that okay now? Okay, so let's look at our Examguide app. Okay, so we have 5 questions there that we need to look at. Let's look at those questions from your app and solve them. Okay, it says find the sum of the prime factors of 180. Now look at this now. Just like what we have here, these are the prime factors of 12. They can ask us to find the sum of it. That is 2 plus 3, which is equal to 5. Here, 2 plus 5 is equal to 7. That is if they ask us to find the sum of the prime factors. They can ask us to subtract the smaller prime factor from the larger prime factor of a number. We can do some mathematical operation even with prime factors. Okay, so let's look at this. They say we should find the sum of the prime factors of 180. of 180. Solution. Now remember, when I gave you a number like 12, because 12 is a small number and we know we can tell all the prime factors. Okay? But for 180, what we simply did here was to say, okay, 1 is a factor, 2 is a factor, 3 is a factor, 4 factor, 6 factor, and 12, right? Because we know it's a small number. But for a bigger number like 180, we may not be able to know exactly the prime factors of that number. So what we do is to divide 180 by its prime factors. How? There is a simple way of doing that. How do we do that? We have 180 okay, to be divided now. Okay, we'll use the prime factors of 180 to do this now. Okay, so this is 2 is a prime factor. Okay, 2 into 180 will give us 90. Is that correct? Okay. Then we go here. 2 again is a prime factor. Into this will give us 45. Is that okay? We'll go again. 2 cannot go here. So what we'll do, we'll go 3. Okay. 3 is also a prime factor. Remember that. So this will be 15. 3 can also go. Do you understand that? 3 into 15 is 5. Then 5 can also go. Is 1. Remember, everything we have here, they are all prime factors. They are all prime numbers. 2 is a prime number, 3 is a prime number, 5 is a prime number. Okay? So they're asking, find the sum of the prime factors of 180. 180. Okay? So in this, 2 is, we are not going to put the 2 all together. So 2, it means that 2 is a prime factor of 180. Remember what we are doing, what we want to get is what are those numbers that are prime factors of, remember they're asking of prime factors of 180. We are not concerned about the prime numbers of 180 that are not prime factors. Do you understand me? I know that 10 is a factor of 180, but we don't have any business with 10 because 10 is not a prime number. We're only looking at prime numbers that are factors of 180. Those prime numbers that are factors of 180 are 2, 3, and 5. 2, 3, and 5. They are the 3 numbers that are prime factors of 180. So they're asking us, find the sum of the prime factors, which are these. So their sum is 2 plus 3 plus 5, which is equal to what? 10. So their sum is 10. Do you understand me now? All right? Okay, so if we had done this listing, we would have seen that 2 will be there, 3 will be there, 5 will be there. Every other thing that is factor of 180 will not be any other prime number before 180. These are the prime numbers that are factors of 180. Do you understand the point now? So we just did the addition of it. Okay? Okay, so the option there is option A. We go to the next one. Express 112 as a product of its prime factor. As a product of its prime factor. Now, this is how to approach such questions. When you see it in your exam. This is how to approach it. So they're asking us to express 112 as a product of its prime factors. To do this now, simple. What they're asking us is multiply the prime factors of 112 together so that they will give you 112. But then don't break your head too much. Just come. Do this same thing I did here on this. Reduce the number. Okay? So have 1, 1, 2. Okay, let's do this division. So 2 is a factor here. 2 in 11 is 5, remainder 1, you put it here, it becomes 12. 2 in 12 is 6. Okay, 2 in 5 is 2, remainder 1, that is 4 now, right? Remainder 1, you put it here, it becomes 16. 2 in 16 is 8. 2 can still go. 2 in 2 is 1. 2 in 8 is 14. 2 can still go. 2 in 14 is 7. What can now go? 7. 7 in 7 is 1. All right? Now, whenever they ask you to express a number as a product of its prime factors, all the prime factors you use to reduce that number to 1, multiply them together. Do you understand? So this will be equal to 2 times 2 times 2 times 2 times 7. 1, 2, 3, 4. 1, 2, 3, 4. Okay? So this will now be equal to, since this is 2 times 2, if you check your options, you won't see anything as that, as 2 times 2 times 2. So, okay, so what they did was to put this thing in index form. Index form is how many times did 2 appear? Put it as a power of 2, okay? 1, 2, 3, 4. So this means 2 raised to the power 4 times 7. This is the, we have expressed 112 as a product of it, because if we multiply all this now, it will give us 112. If you multiply 2 times 2 times 2 times 2 times 7, it will give us 112. Is that okay now? Okay, so the next one, so the answer is E, 2 raised to the power 4, right, times 7 raised to the power 1. Raised to the power invisible 1. Hope you know that. Okay, so let's move to the next one. We have express 108 as a product of its prime factors. Express 108 as a product of its prime factors. So let's look at that. 108, want to express as a product of its prime factors. Okay, so we have 108. Okay, let's look at these now. 2 is the first factor that we can use, because if we use 1 as the factor, it will still be 108. So remember, I want to reduce it to the lowest form. Okay, so 2 in 108, 2 in 10 is 5, 2 in 8 is 4, right? Then 2 can still go. 2 in 5 is 2. Remember 1, put it to 4, it becomes 14 there. 2 in 14 is 7. Can 2 go? No, because 2 is not a factor of 27. What is a factor of 27? 3. So 3 in 27 gives us 9. Is that okay now? Okay. So what do we do next? We now come to this 9. We reduce it again by 3. 3 in 9 is 3. Right? Then we reduce it again. Remember, the end point is make sure you reduce to 1, just like we do in LCM. So 3 in 3 is 1. So they're asking us the express, what is it called? 108 as a product of its prime factors. Now, if we look at that, this means equal to 2 times 2 times 3 times another 3 times the last 3. All right, so this will give us equal to, how many times do we have 2 here? 1, 2. So this is 2 raised to power 2 because it's 2 in 2 places, times how many? 3? 1, 2, 3. So this will be 3 raised to power what? 3. So that is the answer. 2 raised to power 2 times 3 raised to power 3. 2 raised to power 2, 3, 3. 2, 2, 3, 3. So that is option B, 2, 2, 3, 3. 2, 2, 3, 3. Okay? 2, 2, 3, 3. So let's look at the next one. Find the positive difference. Let's look at this now. Find the positive difference of the prime factors of 40. Find the positive difference of the prime factor of 40. So let's look at 40 and look at the prime factors of 40. Then we'll look at the difference now, the positive difference. 2, 20, 2, 10, 2, 5, 5, 1. So the question is, what are the prime factors of 40? It is 2 and 5. But the question says, find the positive difference of the prime factors of 40. Positive difference in mathematics means subtract. We can only find positive difference when we subtract a smaller number from a larger number. It will give us a positive difference. But when we subtract a larger number from a smaller number, it gives us negative difference. So by positive difference, they mean that we should subtract the smaller number from the bigger number. That is 5 minus 2. To be what? Equals to 3. Equal to 3. Remember, if this was to be negative difference, it would have mean 2 minus 5 to be equal to minus 3. This is negative difference. This is positive difference. Okay, so, but for the question we are given for positive difference, the answer is option B. That is 3. Now, there is a question here. That question says, find the sum of all the factors of 17. All the factors of 17. Sum of all factors of 17. All the factors of 17. It means we'll have to write out 17 and bring out all the factors of 17. Right? Right? So, what are the factors of 17? Number 1 is 1. Right? Just like we did in 12, in 20, and all that. So, if we put solution there, for 17, okay, we have 1. Is 2 a factor of 17? No, because 2 divides 17, there will be a remainder of 1. What about 3? There will be a remainder of 2. 4, there will be a remainder of 1. 5, there will be a remainder of 2. Okay? 6, there will be a remainder. 7, it cannot even go at all. 8, 9, 10 cannot divide without remainder. 11 cannot divide without. 12 cannot remainder. 13, 14, 15, 16. The only number after 1 that can divide it is what? 17. So the factors we're talking about is 1 and 17. But look at the question. The question says, find the sum of all the factors of 17. Find the sum of all the factors of 17. The question did not say, find the sum of all the prime factors of 17. Do you understand the point now? Remember we said 1 is not a prime number, but the question did not say we should find the sum of all the prime numbers that are factors of 17. No, factors of 17. 1 is a factor of 17. Remember I said 1 is a factor of any number. 1 is a factor of any number. So, to find the sum of all the factors of 17, it is simply 1 plus 17 to be equal to what? 18. So the answer is 18. So that is the sum of all the factors of 17, 18. Is that okay? So we can have some of these things. Let's take this question. 6. Find the LCM of the prime factors of 120. Find the LCM of the prime factors of 120. Find the LCM of the prime factors of 120. So let's look at this now. Let's take this solution. So let's look at 120. So we do our 120, reduce it to its simplest form, 2 here. 2 in 12 is 6. 2 in 0 is 0. 2 here. 2 in 6 is 3. 2 in 0 is 0. 2 here. 2 in 3 is 1. Remainder, 1, we put it here, it becomes 10. 2 in 10 is 5. Can 2 go? No, 2 cannot go. So 3 in 15 is 5. Then what can go again? 5 can now go. 5 in itself is 1. Is that okay? So the question says, find the LCM of the prime factors of 120. Find its LCM. Do you understand me now? Okay. So what we do is, what are the prime factors of 120? The prime factors, to do this is to identify the prime factors of 120. So the prime factors of 120 are 2, 3, and 5. So the question is asking us to find the LCM of 2, 3, and 5. So the question of prime factors can come in any form in your exam. So just understand what the examiner is asking you to do and make sure you do the correct thing, okay? So what we do simply is to do the LCM. So the LCM of 2, 3, and 5. So we look for the LCM, okay? So say 2, 3, 5. Remember, I have told you, if you have seen our class on LCMs or on fractions, something like that, I've said when you want to look for LCM of numbers that do not have common factors, just multiply them. It gives you their LCM. Okay? I know that the LCM of this will eventually give us 2 times 3 times 5. Okay, but let's do this. The answer will be 30. Do you understand? But let's do this and see if that is what it will be. So 2, our normal conventional way of doing this is 2 here, 1. We'll bring 3 down because it can. We'll bring 5 down, it can go. We go to 3. We'll bring 1 here since we are done with this one. 3 into itself is 1. 3 into 5, it cannot go. We'll bring it down. Okay, then we'll move again to 5. We'll bring this down. We are done with this now. Then we'll go to 5. 3 into 5, 5 into 5 is 1. So we say, therefore, LCM is equals to 2 times 3 times 5, which is equal to 30. How? 2 times 3 is 6. Okay? 6 times 5 is 30. Okay? So the LCM of 2, 3, 5 is equal to 30. So what they are saying, what they ask, find the LCM of the prime factors of, so the LCM of the prime factor of 120 is 30. We can also do that for HCF, we can do that for anything. Do you understand the point? We can do all that. Okay, so let's look at something that has to do with HCF. Okay. Find the HCF Okay, let's see this now. Find the HCF of the prime factor of 240. Let's look at 240 of 240. Solution. All right, so we have 240 reduced, so 2 here, 24 is 122, 60, 2, 30, 2, 15, 3, 5, 5, 1. Is that okay? So the factors are 2, 3, and also 5. Do you understand? So they are HCF. HCF means their highest common factor. Okay? See the way you do HCF. Now look at 2, 3, and 5. Do they have a common factor? All of them, common factor. Is there anything that they have in common as common factor? If you look at 2 and 3, they have common factor. For example, 6 is a common factor of this and this. Do you understand? 12 is a common factor of this and this. But is it 5? 15 is a common factor of 3 and 5, but not of 2. We're looking for a factor that is common to 3 of them. Now, I don't think there is any factor as that. To apply our method of solving HCF, we have 2, we have 3, we have 5, right? Unlike LCM, in HCF, we don't just divide. We divide all of them by a factor that is common to all. There is no factor here that is common to all. Do you understand? The only factor that is common to all is 1. You know, 1 will keep keeping them as that. So 2, 3, and 5 is only 1. 1 into 2, 1 into this, 1 into this. So their common factor there is just 1. That is the only factor that can divide all of them at the same time without remainder. It's just 1. Okay? So their HCF is just 1. That one factor that can divide all numbers. Do you understand the point now? Okay, let's look at these. Okay, this is find the sum of the factors of the prime factors of 90 and convert it to a binary number. Okay? So we're asked to find the sum of the prime factors of 90, okay, and convert that sum to a binary number. All right? So 90, 2, this is 45, 3, this is 15, 3, this is 5, 5, this is 1. So the prime factors of 90 are prime factors. So therefore, prime factors of 90 are 2, 3, and 5. 2, 3, and 5. So the question says, find the sum of the prime factors. So their sum is equal to 2 plus 3 plus 5, which is equal to 10. And they say we should convert this 10 to a binary number. How do we convert to a binary number? Divide it by 2, okay? So this is then convert 10 to binary. So this is 10. Binary number is a number that has just 2 figure notations. That is 0 and 1. Okay? All right. So because binary number are numbers in base 2, we use base 2 to divide it so that we can convert it to a binary number. 2 into 10 will give us 5, remainder 0, right? We have a class here on this channel on binary numbers, so you can go and find out how we got this thing like this. So 2 in 5 will give us 2, but there will be a remainder of 1. So 2 in 2 will give us 1, there will be a remainder of nothing. Then 2 here, 1 will just take 1 and put here. So therefore 10 in base 2, that is in binary number, is equal to 1, 0. We count from the bottom upward. 1, 0, 1, 0 in base 2. So that is this. So you can just check your learning app for questions that have to do with prime factors. Get those questions, study as much as you can, and get yourself perfected in that particular topic. Until I come your way again, thank you very much.